Hello, I'm Dr. Marion Long and I'm the founder of the Rhythm for Reading intervention program. Today I'm going to talk about phonemes and executive functions in early reading development. We all know that a good education, particularly in reading, sets a strong foundation for adult life. However, the challenge for schools is to provide a broad and rich curriculum that is ambitious, inclusive, and accessible, with high expectations not just for some but for all children. Can neuroscience help schools to achieve this? As researchers gain a deeper understanding of the human nervous system, the main brain networks and their functions, we educators are able to embrace new approaches with greater confidence and bridge gaps in children's development that may hold them back. Right now, it's estimated that in the UK, a quarter of children are not reaching a good level of development by the age of 5. Delays in spoken language skills are likely to affect emotional self-regulation and sustained attention. Subtle or profound impairments in these areas and in early reading skills may impact their education, their well-being, and their mental health. If young children start to learn to read with delays in these executive functions, they may struggle to allocate attention and the cognitive resources that are necessary for processing text with slower or more effortful decoding. This would impact the development of new vocabulary and place increased demand on attention, setting up a negative spiral. According to the so-called Matthew effect, the rich get richer and the poor poorer. This appears to play out. The children who fall behind in reading continue to fall behind as they go through school. This spiraling effect has been described in terms of a relationship between the efficiency of decoding and the development of executive functions. In terms of typical development, parenting that is warm and responsive has been linked with good levels of development in 4 important areas. Firstly, executive functions such as sustained attention and emotional self-regulation. Secondly, spoken language skills prior to starting preschool. Thirdly, fluency and enjoyment in reading. And lastly, academic achievement. Let's now think about phonemes and executive functions. The most obvious milestones of child development include learning to walk, run, jump, and talk. But executive functions are relatively nuanced and reach maturity in early adulthood. They include a child's ability to regulate their emotions, sustain their attention, suppress their impulses, and choose goal-directed behaviour rather than impulse-driven behaviour. It's interesting to consider the relationship between executive functions and phonemes because executive functions are generally regarded as top-down processes, whereas language is processed from the bottom up, primarily as a sensory experience, whether through speaking, reading, or listening. However, in the context of decoding the words on the page, a child in the early stages of learning to read must tackle word reading as a code breaker would, using 4 essential tools. Firstly, awareness of phonemes, the smallest sounds of language. Secondly, knowledge of the correspondence between the letters and their sounds. Thirdly, a visual memory of the shape of each word, and lastly, the cues or nudges that are provided by the context of the words. If we focus on this problem-solving aspect of learning to read, we can see why top-down processes such as executive functions are so important. In this post, I'll discuss the executive functions of working memory, switching, cognitive flexibility, and control of inhibition. However, the control of sustained attention, which is also considered to be an executive function, is a prerequisite for focused reading and learning. If a child is hungry, tired, or anxious, even in the most calm, orderly, and consistent of learning environments, they are likely to struggle to focus their attention and their other executive functions. The development of learning and reading is therefore arrested for the most fundamental of reasons. Given that executive functions develop throughout childhood and adolescence, it is not surprising that researchers have found a general correspondence between the development of decoding ability on the one hand and executive functions such as working memory on the other. We use working memory when we're keeping things at the front of our mind. As children develop into fluent readers, they rely much less on problem-solving skills involved in decoding, such as maintaining the letters and their corresponding sounds in working memory while they figure out how to read each syllable. Decades of research have established that working memory and decoding skills perform in a similar way in children with slower development in their early reading. During the development of early reading, there is a key difference between fragile and fluent readers. This has been explained by the dual root model of visual word recognition and reading aloud. Decoding skills require a phonological processing route for the smallest sounds of language and an orthographic route for the visual recognition of the whole word. Children with fragile reading tend to spend more time and effort in the phonological route, whereas children with fluent reading recognize whole words without effortful phonological processing. This learning difference is likely to ripple out into all areas of learning, leaving the fragile reader struggling with fatigue in the long term unless their reading becomes fluent. Now let's think about phonemes and task switching. Task switching is also known as cognitive flexibility. Imagine a bilingual child who speaks a different language depending on who they are speaking to. Perhaps they speak English at school and a different language at home. This switch from one language to another is an example of the type of immediate shift that children learn to make in many areas of their reading development. The dual root model offers a way to understand the important role of task switching in reading development. Reading experts believe that fluent readers have the ability to toggle between phonological and whole word processing, whereas novice readers do not have this flexible dimension that is thought to be essential for fluent reading. Now let's think about phonemes and the control of inhibition. Inhibitory control means exactly what you would expect. Self-control, of course, plays an important role in children's learning. It's obvious that some children are very distractible. Those who do not focus their attention or suppress their internal impulses are more likely to struggle with hearing the smallest sounds of language. A piece of research that tracked the reading development of children from age 5 to 7 years of age showed that there was an indirect relationship between inhibitory control and awareness of phonemes. Another study, this time of adolescents, found that decoding ability, inhibitory control, and task switching were related. In other words, fragile reading does not fix itself over time. The relationship between executive function, phonemic awareness, and reading fluency persists, and we need to find early interventions for struggling readers as soon as they are identified. In a paper that analysed 65 different studies as well as reading development in different languages, there were 165 statistically significant associations between decoding and executive function skills. The meta-analysis showed that associations were significant and also generated moderate effect sizes for the following executive functions with word reading as well as non-word reading. Firstly, working memory. Secondly, task switching. And thirdly, inhibitory control. Characteristics of different languages made a difference to the findings. Languages such as English, French, Chinese, or Arabic have a deep orthography, meaning that the relationship between the sounds of the words and the way they are written varies a lot. And this is because of the way that these languages have developed over thousands of years. Languages such as Spanish and Greek, on the other hand, are more regular in terms of the relationship between the sounds of the language and their appearance on the page. This is why in English, irregular words such as said or water are taught by visual recognition. Phonemes, the smallest sounds that make up the word, are simply not going to lead the child to the correct spelling. Researchers have studied the extent to which deep orthography affects learning. When they looked at 6,092 most common 1- and 2-syllable words that were extracted from the school books of children aged between 6 and 9, they found that there were 211 symbol-to-sound correspondences, and of these, 166 could be described as rule-based, whereas 45 are exceptions to the rules. The researchers were interested in the age at which the children interacted with the different demands of irregularities between the sounds of words and their appearance on the page. It's interesting that the effective age depended on which executive function was studied. The children's age predicted their performance on task switching. The extent of the relationship between decoding and task switching became smaller as the age of the children increased. In other words, studies which track children's performance on working memory, task switching and inhibitory control and decoding over time show that the strength of the relationship between executive function skills and decoding was more reliable in early rather than late childhood. Languages with deep orthographies, such as English and French, were more likely to demand a more frequent toggling pattern between the phonological and the orthographic processing routes during reading development. But the need to toggle would diminish with age once reading fluency had been established. For weaker readers, however, who do not develop reading fluency, a language with a deep orthography such as English provides an additional challenge in terms of ongoing effortful phonological processing. For these children, there is a spiral of diminishing returns as increased effort leads to cognitive fatigue and a sense of disempowerment. And for these children, there is only one solution: early intervention.